morning, good afternoon, good evening, DevOps friends. Hello, this is Full Stack Live, the live coding and sysadmin stream by Opsitive. I'm Jochen and happy to have you here. It's Tuesday afternoon and I already have a stream down because I did a co-working stream earlier today in which I completely failed to buy a kettle. And today, on this stream, we are going to build a new NAS. I'm very excited because I'm always eager to learn something, and I haven't used true NAS yet. Up until now, I was only able to buy a Synology NAS and put some hard disks in there and call it a day. So that wasn't the pinnacle of system administration at all. Today I'm going to use my new home server running on Proxmox, the virtual machine environment, and I'm going to create a TrueNAS VM and use it with 4 6-terabyte disks that I've also bought and added to my home server. So we'll have to solve the problem of making these physical disks available to the VM so it can actually access these disks directly without any virtualization in between, so we don't lose any performance. And just recently I've been dabbling with NAS technology quite a bit, I have to admit. So first of all, I ran Docker containers on my little Synology 2-disk NAS, and I migrated those containers over to the home server as far as possible. So Home Assistant and Pi-hole are now running on my new home server, which I built out of a Dell Precision 5820 workstation from 2018 that I bought on eBay, and I am very happy about that. Actually, I'm so excited about this new old hardware. Hey Theo, welcome to the stream. Happy to have you here. Yeah, let's build this NAS. Yeah, I'm so happy with this used workstation. It's 5 years old. I actually looked up the service code on the Dell website, and it showed me that this workstation is from 2018. It has a Xeon W2133 in there, which is still pretty capable. It's 12 threads at 3.5 gigahertz, I think. So more than enough to run a few VMs. Got distracted making coffee. You are excused. Coffee is always a good distraction. I had a coffee earlier at McDonald's, so I didn't brew myself a new coffee. Maybe I'll take a break later during the stream and actually make some coffee for myself just to keep me going, because this is the second stream that I've been doing today, as Theo already knows, because I raided him after my co-working stream. That wasn't too productive, but yeah, I did get a few things done. And later tonight, I'm going to have the first Opsitive community call, where we simply hop in an audio channel on the Opsitive Discord together and shoot the shit. So I'm excited to see what happens there and who's going to turn up. Yeah, I'd like to invite everyone to join us there. So there is the Discord. Oh, Fragberg already did the work for me. Thank you very much. Where was I? Yeah, Discord. So I'll have to keep up the energy for so I don't fall asleep during our community call later tonight at 7 p.m. UTC. And by then we should have the NAS working already. I was about to tell you a little bit about what I was doing with NAS technology as well, which was not only porting the containers over that I have had running on my Synology NAS. There are still 2 containers running on the NAS because they are directly connected to the storage, and that's the what is it called? It's called a Tube Archivist. That's an application that downloads and indexes YouTube videos, which makes consuming YouTube much more palatable because it downloads your subscription for you and presents them to you, and you don't get the algorithmic homepage that distracts you and tempts you to watch all kinds of stuff. You only get the stuff that you have actually subscribed to, and that's ready for you to watch right in your local network without having to download anything, because Tube Archivist already did this for you. I might port that over to the new NAS as well, because I think I'll make the Synology NAS my backup system alone, so that the new NAS, the new much bigger NAS, and as well as my workstation will back up to the old Synology machine, and that then will probably also do the offsite backup and upload stuff to, and that's what I was getting to my new cloud storage, which uses Borg as the backup software. So if you're not familiar with Borg is an open source backup software that you can run on Linux, on FreeBSD, on all kinds of systems. And it does your backup for you. It does all the necessary stuff like deduplication, so everything gets stored only once, even if you do, say, hourly backups. And that is really useful. Fragback says, I built a NAS last year. Tell us more. What did you use as your hardware and software solutions? And thank you, Theo, for the praise. It's very humbling. Thank you. Yeah, Borg backup. I did use the Synology provided Hyper Backup software, and I was quite happy with it until I realized that it has quite a few shortcomings. And I realized that when I wanted to, or I thought about also doing an offsite backup of my media archive, let's call it that. And no, it's not a porn collection. It's just movies and TV series that I, of course, ripped from DVD and stuff. So I thought about, okay, how about we back that up? And then when I started to configure that in Hyper Backup, I immediately ran into 2 problems. First of all, Hyper Backup can only do one backup job in parallel. So that means even if I created a second backup job for my media collection, instead of simply adding it to the existing job, it wouldn't run in parallel. It would start when the main backup job would be finished, which usually doesn't take much because I don't change my data that much during the day. So it would get started quickly. However, then it would run for ages because, of course, we're talking about a terabyte of media files. So that'll take quite a few days to upload to whatever backup target I would choose. At that time, I used Backblaze B2. Mike PDX, welcome to the stack. Happy to have you here. Doing great. Just telling people about what I'm doing with my storage systems at the moment and how I'm managing backups. So, yeah, and not until this huge backup job would then finally finish would my regular backups run again. So it would put my regular backups, which are about important data, including business stuff, it would put that on hold for days, if not weeks. And that, of course, isn't acceptable in any way. The second reason why Hyper Backup didn't cut it for me was you can't set upload limits. So even though I have quite a decent upload bandwidth, the backup would then compete for that upload bandwidth, for example, with OBS during my streams. So it would probably impact the stream quality, and I can't have that either. So yeah, I decided that Hyper Backup had to go, and I installed Borg Backup on my NAS, which, since it's a command line application, is of course not as nicely integrated into the Synology DSM software as Hyper Backup was, but it runs nicely. It's been running for a few days now, and I also configured notify.sh to update me on backup status. Notify.sh was actually recommended to me by regular viewer and mod of the channel Exegete.io. And so if the Borg backup would have issues for some reason, or had some issues for some reason, notify.sh would send me a notification to my phone that a backup has failed, and I could then look after things. So yes, Borg might not be as pretty as Hyper Backup, but it allows me to run as many backup jobs in parallel as I want, and I can actually limit the upload bandwidth, which I did for my regular backup job that I set up so far, which means that I can actually get rid of the Backblaze B2 bucket that I've been using so far, and that has my backups for the past months. I can delete that because I'm now using a Hetzner Storage Cloud storage box, it's called, which is basically a storage system that you can extend, a cloud storage system that you can extend, that already comes with Borg support, so it has Borg installed, and you can connect to it directly once you have Borg installed on your client as well. So that was set up very quickly, and it works nicely, and I can now direct other backup jobs there as well. I started with a capacity of 5 terabytes there, and I can extend that if I want or need to. So, new status is the old Synology NAS now gets backupped to the Hetzner storage box using a Borg backup. I'll have to set up Borg backup for the local backup as well, which I simply copy to a USB disk that I've attached to the Synology NAS. So everything will be managed by Borg on the Synology NAS by then. I'm also thinking about replacing Restic, which I'm using on my workstation here, with Borg as well, and simply use the storage box as the target there as well. So everything goes to the same machine. And I don't have to pay different cloud storage providers for different stuff. So let's consolidate a little bit. And then we'll have to think about backup of the new NAS too, because I'm going to have 18 terabytes of storage there, and the Synology NAS only has 6 terabytes of storage, which means I won't be able to back up my new NAS to the old NAS forever. But on the other hand, yeah, we'll have to see how quickly capacity is going to fill up. Let's build the thing first, shall we? Okay, so enough rambling. If you have anything that you'd like to share, if you have open source software that you are excited about, if there is anything that you'd like to ask, pop into chat and let me know. Let's make this thing interactive. While I can do a 2-hour monologue, I don't really like to. So, yeah. Now, let's get ready. So here we are. I called up the Borg website simply to show you the software. Borg is a nice little software that you can actually install and use quite easily, especially with a helper script that's called Borgmatic. And I guess common Linux distributions will have both in their package repositories, so you can simply DNF install Borg and Borgmatic, or simply do DNF install Borgmatic actually on Fedora, for example, and it'll install Borgmatic as well as Borg. The added value you get from Borgmatic is that it allows you to create a configuration file where you can neatly configure everything. Otherwise, if you used Borg directly, you'd have to pass everything in as command line arguments. Having a nice, neat little YAML file is more convenient in my opinion, so I'm using Borgmatic on the Synology NAS. Can't show you the configuration file though, because it also contains my encryption passphrase, which Borg does also. So not only does it do deduplication, it also does encryption. So my backup data is actually securely stored in the cloud. Connections, by the way, between the Borg client and the Borg server usually are via SSH, which means this is also easily set up. Just put your SSH key, copy your SSH key from the client to the server, and that's it. Give me a second. I need to set up here a little. Okay. I guess if you have any question about Borg, let me know. Otherwise, I'll close this tab. All right, here we are on the UI for my new home server. Oh, and by the way, if you'd like to know how it looks like, so what I bought on eBay is a Dell Precision 5820. That didn't work. Shoddy website, huh? Let's go to Dell directly. So that's how it looks like. Oh, come on. Just want to show you a few pictures. And of course they have the tiniest picture you can ever have. Nope, that's not going to work. Dell Precision 5820, and we'll simply use image search. I should have thought of that earlier. So that's how this workstation looks like, and behind that little grill here, we have 4 hot swap hard disk bays, which I've populated with 6 terabyte disks. In this picture, they are actually using 2 M2 slots here. These are special M2 bays, each of which I think costs €100 or so. So I didn't get those, but the machine came with 4 regular hard disk hot swap enclosures, so I can simply pull out disks if they break and replace them while the machine's still running. So that is really nice. And now we'll have to create a VM for TrueNAS scale, which I'm going to use as my with my NAS disks here. And yeah, so let's get to it. Questions are futile. We are the Borg. You will be assimilated. Let's limit the futility to resistance. I will answer questions. Yeah, that was a nice plus. And yeah, I was about to say earlier, buying this thing for a few $100 on eBay, getting a amazingly engineered case with 4 hot swap bays and a still decent CPU, the ability of adding up to a half a terabyte of RAM, that has really opened my eyes for the used hardware market. having a hardware budget from my business has made me a little bit unaware of what's actually available on the used hardware market, and how much money you can save by simply refurbishing or getting a refurbished machine and reusing that instead of buying something new. Of course, that's also not only important from an economical standpoint, but also from an environmental one. So I'm really considering getting more used hardware instead of buying new stuff. And all I had to do was open the case, replace the thermal paste under the CPU cooler, because that had dried up in the last 5 years. Which made me quite queasy, because that's the first time I even had to deal with thermal paste. But that went over nicely. So yeah, I'm learning every day. I'm not really fond of hardware tinkering because I tend to break stuff. But so far so good. And thanks to the hot swap base, I didn't have to build these hard disks into or mount these hard disks into the case. So yeah, now let's get started. As you can see, my 4 6TB drives are already displayed here on the disks list of my Proxmox machine. They are all identical models with different serial numbers, of course. And they are all 6TB disks. So since I'm going to build that as a RAID Z, which is basically the ZFS equivalent to a RAID 5, I lose the capacity of one of these drives and still have 18 terabytes of net capacity left over. I could actually assign these disks to a VM directly, but that would have one downside. They would be added with their symbolic names here, dev, SDA, B, C, and D. And unfortunately, Linux isn't really... I'm reluctant to say reliable in the way that the assignment, what is A, what is B, C, and D, might change between restarts, especially if you replace hard disks or do something like that. So it's much better to use different device names here, and that includes the actual device ID, which is tied to the actual hardware and therefore can't be easily confused. But before we get to that, we'll simply have to create a new VM. So I'll actually go here and say create VM. And the node is, of course, PVE1, which is my Proxmox server here. And I'll have to assign an ID. The IDs I use are grouped into into hundreds. So the 200 region, that's my production VMs. So since 201 is already taken by my Home Assistant VM, we'll call that 202, and the name will be NAS2, since my Synology NAS is already NAS1. I'm not going to have it start at boot, and there's not going to be a resource pool. We don't need any delays, so we'll go ahead and define which operating system to run on. The operating system is stored on my local storage, and the ISO image I've already downloaded is the one for TrueNAS Scale 2212. That's actually Linux. The former version of TrueNAS Core, was actually FreeBSD, but TrueNAS Scale is based on Debian, I think, and so it's going to be a Linux. Now to the system, we'll use the default graphics card, default machine, default BIOS. We'll use the Vertio SCSI controller, and that's all fine and dandy. In terms of disks, at this point I'm only going to define the system disk, and we'll use 20 gigabytes of a virtual disk drive. I'll enable SSD emulation because this storage is actually on an SSD, so it's a good idea to enable SSD emulation and enabling discard so that space management can be done in an SSD-ish way. And all the other disks that we want to use, is the actual data disks, those I'll add later because, as I mentioned already, that needs a little bit of a special approach. Otherwise, I would be able to simply hit the add button here and add them directly. And finally, in terms of CPU power, we don't need too much. Tuna's scale is happy with 2 cores, and we don't need anything extra, I think. But there was one thing that I wanted to do, and that is set the CPU type to host. So all the particulars of my actual physical CPU get passed through to the VM, because I don't know if Tunas will actually use some of them, say, for example, AES encryption support or something like that. If that's even available on the Xeon versions I've built in, I don't actually know. Finally, in terms of memory, we'll use the recommended 8 gigs of RAM. At the moment, I have 32 gigabytes of RAM in the machine. That's what I bought the machine with. I intend to extend that at a later point to 128 gigabytes once I start using more VMs on there. For example, if I do experiments with Kubernetes, I'll probably run a lot more VMs on there, and that will require me to extend the memory a little. So that's that. Network will use the default settings with using my default bridge. So this VM will simply get an IP address from my router as every other machine on the network as well. That's perfectly fine. And thanks to Pi-hole, every machine will also get a host name on the network, or a domain name on the network, so I don't have to deal with IP addresses a lot. Let's take another look. 2 cores of the host CPU, 8 gigs of RAM, name is NAS2. We'll have 1 bridge. The single disk will be the system disk with 20 gigabytes to start. I don't think we'll have to extend that a lot. And we'll use virtio SCSI, and VM ID will be 202. We're not going to start this machine right away, which isn't displayed, but yeah, I can still see that it's not checked. So let's finish this. Now, here Proxmox is now provisioning this VM. We already see 202. Status is stopped. It has assigned the name NAS2, and that means we can now take care of adding the NAS disks. For that, I'll go into the shell for the host system, for the Proxmox system itself, and I guess let's take a look at the available disks from the command line here. So I can use the lshw list hardware command, and I'll simply say list all hardware that is class disk or class storage. It'll scan the whole machine, and here we have a bunch of disks, and these are my NAS disks. Disk 0 is the Seagate. It's a Seagate Iron Wolf Pro with 6 terabytes, and the first one has the serial number WWZ Z Z Z2 NSFE. 6,000 gigabytes. Then disk 1, same model, different serial number, and so on and so on. What I don't want to do is use the device logical names that Linux has assigned to these disks. So I'm not going to use dev SDC because that's this assignment isn't laid in stone, and of course I don't want my RAID to break simply because two drive letters get swapped. And that's why I'm going to use something different. Linux has device names under /dev/disks that have specific IDs. And so under dev disks by ID, I think it's dev disk. Yeah, dev disk by ID. We have our disks here, both the DVD-ROM that's also built into my home server, and the 4 NAS drives. And as you can see, these NAS drives now have specific device names that not only contain, in this case, the model number, but also the serial number here at the end of the name. So here we have WRQ1PP0K. Here we have the WWZ2D56X, and so on. And these names, since they even contain the serial numbers of the disks, these are unambiguous and unique, and they are ideal candidates to use to add them to my NAS VM. And that's exactly what we're going to do here. So what I'm going to do is use the Proxmox command line tools to add these disks. Let me take another look at my VM though, so I can actually see how the drive slots are assigned. Here under hardware, I can see that disk 0 is assigned to the 20 gig system drive, and that's SCSI 0. So we can use SCSI 1 and following for our NAS disks. Let's go back to the Proxmox shell here. Yep. And so what I'm going to do is use the qm command. Qm, oh, wrong window. Qm set, then the VM ID 202, and we'll set SCSI 1, which is the first free slot we have, to, let's list the directory contents first again. I guess, can I use cursor up? Yeah, I can. So, qm set 202-SCSI 1, and we'll use the first drive. Oops, this doesn't work. Let's see. Is there a way to copy and paste? I guess I'll have to copy first. I think copy didn't even work. So let's see. Let's copy that. And then we'll paste it again. Oop. There are control characters in there that shouldn't be in there. Let's not confuse everything here. Let's try again. Let's see if I did something wrong. Copy. paste. This time it worked. Okay. It said update VM202. Now we have SCSI1 defined, and we'll do the same. Yeah, that's force of habit. I used Control W to delete on the command line, but that, of course, since I'm working in a browser, would have closed this tab. Let's stay on this page and use the backspace key instead. Okay, so SCSI2 is going to be this second disk here. That update worked nicely as well. Let's then turn our attention to SCSI3, which is going to be the drive down here. Okay, and last but definitely not least, SCSI4. That's it. Okay, so now let's check that everything has been attached successfully. We'll have to take a look at the VM definition. I could do that on the graphical UI actually, but I can also go into the configuration of my VMs here, and we can simply take a look at the definition file for my VM number 202. And as you can see, here are all the details that we already had before, including the ISO image that I'm going to use to boot from. That's connected to IDE 2, actually, in this VM. And then we have SCSI 0, which is the virtual disk with 20 gigs that I created earlier. And then we have SCSI 1, 2, 3, and 4, all with different serial numbers. And the same size, which, yeah, is to be expected. One more thing that I'd like to do is actually pass the serial numbers through to the VM as well. Even though they are included in the device file name, that's not how the VM will actually know about these serial numbers. I'll have to actually hard code them in the configuration. But that's easy because I can simply copy my VM configuration file to a backup. So let's copy to conf to my root home directory called 202conf backup. And now we can actually use vim to edit the configuration file. And the nice thing is I can actually simply add a key named serial here. Oops, nope, not there. Up here. And let's do this first of all, these lines. And thankfully, I don't have to look up the serial numbers, since they are, in this case, included in the file name. So I can simply copy this and add it at the end. And with that done, I can actually save that. And now let's take a look at our VM definition here. As you can see, Proxmox has already picked up on these changes. We have hard disks SCSI 1, 2, 3, and 4 with the actual unique file names using the disk IDs instead of using the logical names SDA, B, C, and D. And even the serial numbers are reported to the VM, which means that TrueNAS will actually see these serial numbers, and should I have to replace a disk with an identical model, TrueNAS will actually pick that up, because the new model will, the new disk will have a different serial number. And that should do the trick. I think we are ready to install TrueNAS. So let's go ahead and start this VM. So we'll start the TrueNAS scale installation. Can I make this a little bit bigger for everyone's benefit? It'll just make the window bigger, but that doesn't really help. Okay. TrueNAS console setup, install, upgrade. Yes, please. Install TrueNAS to a drive. I'd like to install TrueNAS to SDA here, which is the QEMU hard disk with 20 gigs. Warning, this will erase all partitions. Yes, that's fine. Web UI authentication method. Administrative user admin. Yep. Enter your admin user password. Let's do that. Give me just a second. Allow EFI boot. Enter yes for systems with newer components, such as NVMe drives. Enter no when system hardware requires legacy BIOS boot workaround. I haven't set up an EFI partition, so we'll go without. I don't think that's going to be an issue. It says can't find SDA3 or SDA-P3, not a block device. TrueNAS installation on SDA has failed. Okay, maybe I should add an EFI partition. Let's shut down the system and do that. So I can simply go into the VM's hardware and say add another device, in this case the EFI disk. EFI storage. Oh, it says VM currently does not use OVMF UFI as BIOS, so we'll have to change that too. The EFI disk will be on local LVM. And we're not going to pre-enroll keys because we're not going to use Windows on there, so I don't think that's necessary. And then we have to change the BIOS to EFI. Now let's give this another try. Let's use this console here. Start TrueNAS installation. Let's see how this works. Now, install and upgrade. We'll install on SDA. Proceed. Administrative user. This looks a little bit better. The nice thing about these VM setups is that if I made any kind of mistake and I notice that early enough, I can simply throw away everything and restart, and do that even from the convenience of my desk. Almost done. Tuna succeeded. Please reboot. Reboot. So let's do exactly that. Let's boot Tuna scale. That's hard to read even for me here at my screen. Apparently it did a kind of an update. And now it's loading all kinds of stuff. Is something not right? Oh, here we go. And here we are. And I should be able to access TrueNAS directly on the web interface. As far as I can see, 222 is the IP address, so let's use that. And since TrueNAS even has apparently provisioned at least self-signed certificates, we should actually be able to use SSL here, even though it's self-signed, so I'll have to accept the risk. And here we go, TrueNAS. And let's log in. Username admin, password secret. And we have it running TrueNAS. Very nice. That looks great. Link state is up. I guess. Let's check storage dashboard. There is no pool, so let's create one. And it offers me the 4 up until now unused disks. So I can simply say, okay, this pool is going to be named Rust, because it is actually spinning Rust. It's iron dioxide on a platter that rotates very quickly. And we'll simply check all 4 of these disks. And with 4 disks, we could, of course, do a RAID Z2, but that would only give us 10 terabytes out of the 24 that we have. So let's do a RAID Z, which still leaves us with a little bit more than 16 terabytes, and the ability to lose 1 disk without losing data. Everything else needs to be then covered by backup. So we have those, and that's VDEF1. So let's do create. Contents of all disks will be erased. Yes, I can confirm that I'm happy with that. TrueNAS now creates a ZFS pool. And even though I have headphones in, earplugs in, I can hear the disks rocking. Okay, here we are. Rust. RAID Z1 over 4 5.46 terabyte disks. Usable capacity about 16 terabytes, of which 0% is used. ZFS health is online, 0 errors. The scrub task is already set. That is ZFS checking the integrity of the pool on a regular basis. Auto trim is off, and it doesn't need to be on because we are not dealing with NVMe drives or SSD drives here. Disk health is okay. No temperature related alerts. Actually, there is no data. So yeah, okay. Failed smart tests 0. All right. That's that. Now, next step would be to create a data set. And that's when I have to think. No, we already have a data set here. That's Rust with 16 terabytes. And let's see. What do we have here? I'm actually new to ZFS, so that's definitely learning opportunity. Balthazar, hello, welcome to the stack. We just set up true NAS on the home server with 4 6TB drives, resulting in a 16TB RAID Z storage pool. It's a true NAS scale. Now, we can actually go ahead and start defining shares. And I haven't actually thought about what kind of shares I'll need. So I guess I'll definitely need some kind of user shared. Exegete, welcome to the stack too. Good to have you. Everyone's popping in. I've just finished setting up TrueNAS on my home server after passing in for physical drives.